On a long horizontal moving belt, a child runs to and fro with a speed of 9 km per hour with respect to the belt between his father and mother located 50 meters apart on a moving belt. The belt moves with a speed of 4 km per hour. For an observer on a stationary platform outside, what is the speed of the child running in the direction of motion of the belt? So there are three questions. Let us take each one by one. So this is the situation given in the numerical. This is a moving belt. The belt is moving with a speed of 4 km per hour. The child is running between his father and mother. So this is the father, this is the mother. This is a stationary observer. So the father and mother and the child, they are all moving on a belt which is running at a speed of 4 km per hour. But the child is running between his father and mother who are at a distance of 50 meters on the belt, on the moving belt, with a speed, the child is moving with a speed of 9 km per hour. Now what is that we are supposed to calculate? The first question is speed of the child running in the direction of the belt, right? So if this is the father and this is the mother, and you have to calculate this according to a stationary observer. So the first two will be calculated for a stationary observer. So this is the father, this is the mother, and you have a stationary observer here. This is a stationary observer, and this is the child who is running with a speed of 9 km per hour between his father and mother. So the belt is moving with a speed of 4 km per hour. Now since the boy is moving in the direction of the moving belt, for a person who is stationary, he will see that the boy is actually moving with a speed of 9 km per hour plus 4 km per hour, which is the motion and which is the velocity of the child or the speed of the child plus the speed of the belt according to a stationary observer. So in this case, the solution would be case 1, that is A, the velocity of or the speed of the child according to the stationary observer, right? So the speed of the child with respect to the observer on the ground. Will be the speed of the belt, which is speed of the child plus the speed of the belt, which is 9 plus 4, that is 13 km per hour. So what's the next question? The speed of the child running opposite to the direction of motion of the belt. So in the second case, what happens? In the second case, so the child is moving in the opposite direction. So this is the father, this is the mother. So this is the father, mother, and the child. So the child is moving in this direction, whereas the belt is moving in this direction. So in this case, the speed of the child according to the stationary observer will be speed of the child would be the speed of the belt, speed of the child, it is 9, right? This is the speed of the child plus the speed of the belt, which is moving in the opposite direction. So I have taken this as positive. So the speed of the child will be, the belt is, it will become -4 because they are both moving in opposite directions. So the observer would now see that this child is moving with a speed of 5 km per hour when he is running in the opposite direction as earlier. So the next question, time taken by the child in A and B, which of these answers alter if the motion is viewed by one of the parents? So you have to calculate the time taken by the child to move on the belt as seen by the parents actually. So you see, In this case, the child, the father and the mother all are in motion on a moving belt which is moving with a speed of 4 km per hour, right? So according to the father or according to the mother, the child would still run with a speed of only 9 km per hour because they're all in motion, they're all in a frame that is moving with a speed of 4 km per hour. Therefore, the speed of the child would only be, so speed of the child with respect to parents. In either case, it is only 9 km per hour. So what is the distance now? Distance between the parents? Distance between parents is 50 meter, right? So this is in meter, this is in kilometer per hour. Therefore, I will convert this into meter per second. So to convert it into meter per second, you have to multiply by 5 by 18. So 9 ones are 9 twos are 5 by 2 is 2.5 meter per second, right? So you can easily calculate the time taken by the child according to the parents to cover a distance of 50 meters. So time is what needs to be found out. So time, we know speed is equal to distance by time, distance into time. So distance, if I call this as y into t. So the speed with which he is moving according to parents is, velocity. Sorry about this part. So we know y is actually equal to v into t, that is distance is equal to velocity into time. So this is distance is 50 meters, this is 2.5 into t, hence t will be 50 divided by 2.5. Now if you multiply this by 10 by 10 to remove the decimal place, you get 500 divided by 25, which is 20 seconds. So the value of t is 20 seconds. So according to the parents, the child actually takes 20 seconds to cover a distance of 50 meters, moving with a speed of 9 km per hour or 2.5 meter per second. Right? Now, which of these answers will alter if it is viewed by one of the parents? See, none of the answers will alter. It would still remain t is equal to 20 seconds, right? So both the parents will see that the child takes a time of 20 seconds to cover the distance because the child, the father and the mother all are moving with a speed of 9 km per hour, 4 km per hour, which is actually the velocity of the belt. So therefore they are all in the same reference frame, moving reference frame. Therefore the child would still take 20 seconds as seen by either of the parents.